So hello guys, we are going to discuss the question from JEE Advanced Paper 2025, and it is, we know from the diagram that it is of the capacitor topic. Okay, to be precise, it is of the cylindrical capacitor. Alright, we have to understand the question first, that two coaxial conducting cylinders of same length and radii root 2r and 2r are kept as shown in the figure. Root 2r will be the inner radius, as we can see in the diagram. It is the inner radius, and outer radius is 2r, right? So this is 2r. Okay, so next thing is the charge on the inner cylinder is given as q. Outer cylinder is grounded. Make sure it is grounded, right? So, and the annular region between the cylinders is filled with the material of dielectric constant K equal to 5. Most important point. Consider an imaginary plane of the same length L and at a distance r from the common axis of the cylinders. We can see in this diagram that this imaginary plane, we can see from point A, B, C, D, that is a dashed line, which it is an imaginary plane, as a cross-sectional a photo of image of the given question, and that plane is from center, it is at distance r. Alright, moving ahead, this plane is parallel to the axis of the cylinders. The cross-sectional view of this arrangement is shown in the figure 2. We are ignoring the edge effect. We are asked to find the flux of the electric field through the plane. Alright, epsilon naught is the permittivity of the free space. There are four options given. So how to find this answer? First of all, we have to recall the theory of concentric spheres, right? And we understand when the two concentric spheres were given, outer one was grounded and inner one was given as charge q. The electric field was found only between these two spheres. We can say it as the annular region, right? So electric field is only between these two one. So similar case is happening here, that between two cylinders, electric field is only found between these two, not on the outside, not on the inside. So electric field outside will be 0, inside will be 0, right? Okay, so what will be the electric field passing through this particular region, which is AB and CD only, right? So outer points, there is no electric field passing through these regions, and that is why we can say that no flux is linking with these particular outer areas and inner areas, right? So how to find this one? Okay, so we have to understand the angles first of all. We can consider the triangles. Let's say the triangle, from the diagram we can see this is point O. So in triangle OEC, right, it is, let's take cos theta. So cos theta 1, let's understand this is theta 1, right? So cos theta 1 would be the adjacent side, which is given as r, and the hypotenuse OC. Now OC is the radius of inner cylinder, which is, we know that it is root 2r. So divided by root 2r is equal to what? 1 by root 2. From here we can get the value of theta 1 will be how much? It is 45 degrees. Okay, we are going to discuss the same thing for the triangle OED, right? Taking theta 2 as for this particular triangle, so cos theta 2 will be equal to adjacent again for r, and hypotenuse will be 2r, outer radius 2r. So from this one we can get theta 2 to be 60 degrees. All right, so how much will be the angle COD? That will be 60 degree minus 45 degree, which is equal to 15 degrees, right? It is 15 degree. So that particular angle is 15 degree, and the another one is also 15 degree. So you can consider the whole angle is 30 degree. The area linking, है ना, the area which is linked with the electric field is of the 30 degree. Now what will be the flux passing through this one? So flux will be what? Flux is equal to charge given divided by epsilon naught, but here the medium is given, so epsilon will be there for the medium. Alright, so it is charge divided by k epsilon naught, but we know that this much is only for what? Only for the whole 360 degrees, but 30 degrees only divided, है ना? 30 degrees only linking with the electric field. So 30 divided by 360, and also we have to get the value 1 upon k, so that this will become epsilon naught. So now what will be the answer? We place all the values, we'll get q divided by k value is 5 and this will be 12. So multiply by 12 epsilon naught. Your answer will be charge divided by 60 epsilon naught. That is option C. So flux linking through this particular given area is q by 60 epsilon naught. Thank you.